I'm Gabriella Vigliocco, and I am Professor of the Psychology of Language in the Experimental Psychology Department. I am also the lead for the Liverulm doctoral training program for the ecological study of the brain. The Ecological Brain is a 4-year PhD program that aims to provide to the next generation of researchers the tools for studying the brain in the real world. It is a highly interdisciplinary program that involves disciplines like psychology, neuroscience, education, computer science, geography, engineering, and architecture. The research that the students will carry out will ask questions concerning how the brain operates in real-world environments, and also how we can change the environment in order to make it better for how the brain operates. The approach we use bridges between the laboratory and the real world. We bring the laboratory into the real world by using mobile recording devices that are now available, and we bring the real world into the laboratory, not only using virtual reality, but also taking advantage of large-scale laboratory spaces where we can reproduce the environment under controlled conditions. Language is the amazing human ability that allows us to learn and to share experiences and emotions in the present, from the past, and into the future. My research question is, how does this work? How can language, being spoken or signed, link to evoke these experiences? How did this ability evolve? How is it learned? And how does the brain orchestrate it? Crucially, communication in the real world is between at least two people, and it's mostly in face-to-face scenarios, in specific environments filled with objects and other people. My current focus is on how all the verbal and non-verbal cues are integrated in the brain to the service of successful communication. Language is a unique human ability that arguably we do not share with any of our non-human relatives. Understanding how it has evolved, how it is learned and used is at the core of understanding what humans are made of. Language is also fundamental to our lives, as it is most dramatically demonstrated when it goes wrong. For example, when a child does not learn language, or when an adult loses language as a consequence of a stroke. Understanding what neural networks underscore the verbal and non-verbal elements of communication can impact rehabilitation and therefore improve the condition of people with language disorder. We have recently challenged one of the most basic tenets of language study, the idea that language is a system of arbitrary, abstract symbols. We have shown that language is not just arbitrary, but is also iconic. Across the world languages, we can see this readily in onomatopoeia, but also in gesture that accompany speech. For example, if I'm talking about a piano performance, I can move my fingers like playing a piano. We have shown that iconicity across both spoken and sign languages supports language learning and language processing, and arguably has played a role during language origin. In another line of investigation, we have asked how we represent and learn words that refer to things that are not tangible, are abstract, words like hope, freedom, and faith. Communicating about the abstract and hypothetical is crucial for most of our social and cultural activities. But these words are learned later and are harder because the environment cannot provide any cue to their meaning. So how do children learn them? We have found that a key property of these words that make them easier to learn is that they tend to have emotional connotations. And we have developed computational models that provide a mechanistic account of how these words are learned and represented.